the machine has to learn. So the machine learning helps the system to study and implement the algorithms that learn from the examples and experience instead of relying on the hard code rules and make predictions on the new data. So, what do you mean by hard coded rules? Hard coded rules are nothing but our traditional programs that way only. To find biggest number, I have a statement. What is that statement? I will input A and B, then I will check if A is greater than B. I will declare A is biggest. Otherwise, I will declare B is biggest. So, this is a one dimensional view of the data. But the data has multiple dimension like how a human has. I cannot be declared as a good person or a bad person seeing one dimension of a data. So the multiple dimensions of the data is what makes the algorithm work effectively. For doing this, we have different types of algorithms, and one such algorithm is the ANN, and the next level of ANN is the deep learning. So let us deep dive into first ML. So now we know the clear idea what is this AI, ML, and DL. So AI is the overall area, which is a kind of engineering of making intelligent machines and program that can be done with the help of machine learning so that the machine will learn and then become intelligent. And there are many such algorithms existing, and one such algorithm is the deep learning algorithm. And deep learning algorithm is based on the neural network, or we can say that deep neural network. So the fundamentals of machine learning. So I'm starting with ML. Since we know AI is the nothing but to get the AI, the machine has to learn, right? So now how the machine is going to learn. So we know that the machine learning is a subset, and how the machine is going to learn. What is the input for the learning? So for anybody, for a human also, the main input for the learning is the knowledge or the data. I should get some data. From that data only, I can actually get the knowledge. I see the environment. I learn from the environment. So when I'm seeing the environment, what I get is the data. So obviously, the machine should be learning from the data in the sense the core ingredient for learning is the data. And after learning, the next level is okay, with that, I am doing the prediction. So I am making predictions. Similarly, the machine also is making the prediction. Will always the predictions will come correctly? No. Even we make mistakes. Then what we do actually, when we make mistakes, then we will make sure that next time this mistake will not happen. So the same thing is for the machine also. First time the machine is making a prediction, and then it will make sure that the prediction is always perfect. It recorrects or it redesigns the system, it redesigns the algorithm so that the prediction is always correct. So this has lot of algorithms which mainly works on the large amount of data. We always say, right? See, like we say that Kenneth Tavala means like I cannot see one environment and I cannot come to a conclusion. I need to see the ocean, then only I can come to a conclusion, right? So the same thing here. You cannot give one data and train the machine. You need to give large amount of data. So the data is being given to this algorithm, and that system is getting trained, and on the basis of training, they will be building a model. So model is nothing but the inference from the data. Seeing the data and coming to a conclusion. For that, using that, I will be performing a task. So what are the types of machine learning algorithm? So all these things everybody knows because I hope most of us are the teachers. But anyway, I'm just giving a snapshot that there are many types of algorithms which comes under the category supervised, unsupervised, reinforcement learning. So supervised is nothing but the machine is trained with the help of a mentor or a teacher. So here what we have is you will be having a labeled data. So what do you mean by labeled data? Labeled data is nothing but you have the data. The data is already labeled that whether it is correct or not. So you are trying to tell the machine that see this is if this kind of data is coming, it means you have to take this kind of decision. So you have already made a conclusion. You already have a knowledge book. The knowledge book is being given to the system. With that, the system is coming to a conclusion. So the supervised learning, you have classification and you have regression and many more under that category. You can say that nail-based classifier or decision tree. We have lot of variations of those algorithms. So variation in the sense in decision tree we have multiple types of decision tree algorithm. Like that, all these algorithms got evolved on a timeline basis. And similarly, unsupervised learning. Unsupervised, again, here there is no labeled data. You go to the environment and learn from the environment. So that we have clustering. Under clustering also, we have different types of techniques. And finally, the reinforcement learning. And even people will say semi-supervised learning. It is all up to them. You can get an algorithm and you can put them into any of this category based on your data. So the reinforcement algorithm also, what is my expected output? Based on that, I'll be fixing my inputs. So this is a kind of hard-coded decision making learning, right? And most frequently used algorithms are the supervised learning algorithms, and the next level is the unsupervised algorithms. And if you take in research, suppose some people are doing PhD, we are doing research. Okay, ma'am, then we will be in, we are in, since you said supervised learning is used, then I can go for supervised. Not necessary. What we can do is we can go for a ensemble method. Means that I can use a combination of supervised algorithm, unsupervised, and reinforcement also. So it is good to know about all the algorithms in bits and pieces so that put together you can create a framework to solve a particular application. Ultimately, we are going to solve an application. So to do that, we should have an idea about all the algorithms. So another, I thought of instead of explaining again and again, I thought of showing in a diagram that may be helping us. So if I take in supervised learning, in supervised, actually, what are the types of algorithm we have? We saw, but what is the process actually? So this is a very simple process. You could see that how actually we have an input and how we derive the ground truth, or we can say the output. So in between, what you have only is changing the algorithm. So here you can see that we'll again come back to this algorithm when we start with the deep learning. So here I have shown some different types of neural network variations. And if you see that everything has the input as image and everything has the output as the prediction. But in between, what the process what we do has a slight changes. So that actually differentiate these kind of algorithms. And you could see how it is done in a unsupervised learning algorithms also. So let's move on. So let's start with the first. So a basic. Now, we had a basic of what is actually a deep learning. So what is the first step? What we have seen is we know what is AI, we know what is ML, and deep learning is a part of a ML algorithm which is called ANN. So first we have to know about ANN. Before we go to ANN, we'll start that which is the most important ingredient for all these prediction. The most important ingredient of all the prediction is nothing but the data. Just like how a human learn by seeing the things around, the same way the system is also going to learn. So in that case, what I need to know is I need to have the data. So the data is the biggest input for an algorithm. Now there is a question how the data has to look like. So if I say that the data is like some 10 or 5 or 10, that is also a data. Aruna Devi, that is also a data. Everything is a data, right? Now the next step, how am I going to organize the data? Why organization matters a lot? Because now remember how your brain is storing the data. The brain is not storing the data in a memory cells. The brain is storing the data in a and the files will be named as per the serial number or exercise number or as per what actually it is. Suppose the Python program for data frames. So I will name it as data frame program, matrix program. Like that we will organize. So we organize the data as per the meaning. The computer organize the data just by filling the data into the memory cells. So now the thing is here how you organize the data matters a lot. So how am I going to organize the data for my algorithm? So I can put it in, suppose if I have one data, I can put it in one variable. If I have a collection of data, generally what we do with collection of data, we'll put it in array, we'll put it in, a file or something that way. So now here, what I'm going to do is, when my data dimension is increasing, I need to go for a multi-dimensional data model. So what is the multi-dimensional data model we frequently use? We use a data model called as matrix. So the matrix you can create with the 2 dimension, 3 dimension, that way, and you can place the data. But now what happens is over the years, as we said, the data is growing so high. Especially if I take a image data, the image data has multiple dimension. Why it has multiple dimension? We know very well the image has a 2 dimension x and y, but I have multiple images, right? Suppose if I want to classify a cat image, so I have 1,000 cat images. So 1,000 cat images, each cat image has one x and y coordinate. Now this data becomes a 3 dimensional data. Now, when I'm giving a training of a machine, to classify whether it is a cat or dog, then I also should be giving the dog information also. Then again, dog is coming into picture. Now this becomes a 4 dimensional data. Like that, my data dimension is going on increasing. That way, I cannot go with the conventional data model. I have to go with the multi-dimensional model. The answer for that is nothing but the tensor. Tensor is nothing but it helps you to create multi-dimensional data array. So tensor is nothing but you don't need to worry. Tensor and deep learning, whether it is connected, no, not at all worry about that. Tensor is nothing but it is a generalization of a matrix model to any dimension. Because we know very well, vector is nothing but an array. A single dimensional data means it can be handled with a vector or an array. If it is a 2 dimensional data, that can be handled like a matrix. But my data has a 3 dimensional or a 4 dimensional or 5 dimensional model. So the good solution is to go with that is the, I can go with the tensor data. Means that you need to create a tensor for storing that kind of data here, right? And then a minute, yeah. Yeah. And then the next thing is, okay, I have a data. How do I create this? Because we know very well that in a normal, what do you call, in a normal program, we know how to create array, we know how to create a matrix. But here, how do I create this? So you have in Python and in many of the data analytical tools, it comes with the tensor as a add-on package. So you can use that and you can create it. So means that what are we trying to do? We are creating n dimensional array. So here you can see that I have shown here how in Python we can do. In Python with normal NumPy package, I can just create a n dimensional array telling that what is the shape and what type of data. This is a very preliminary level, but we should know the power of the tensor. So you have heard that tensor flow. So tensor flow actually gives not only the data but also gives multiple methods to handle the tensor data and to perform the deep learning models. Okay, so now we know how to make the data ready. And the next thing is, okay, can I give the data in one shot for training? Because now what we have said is today's topic is deep learning. Deep learning is an extended version of your ANN. ANN actually belongs to supervised learning. So when you say supervised learning, your data has a label also. So what do you mean by that? So the system has to be trained, like how we do the training in the class. So we will be giving 100 cat images and tell that, okay, this is cat 1, this is also cat, this is also cat. Like that, you are giving some 100 images and telling the system these are the cat images. And once the system has learned, then what are we supposed to do? Now you give an image and ask what image it is. So it should tell whether it is a cat or not. So you have a training phase, you have a validation, you have a testing phase. So how am I going to do is, so what actually we do in the class? So we go to the class, we do the training. So how am I training? I'm saying that this is a topic and I'm giving the answer. And during testing, what are we doing? We are asking only question but not giving the answer. So the student is writing the answer and we are trying to correct. And imagine in end semester examination, what are we giving actually? We are giving a question with the, we are giving new question which the student has to answer. So here also we have the things like, in the training you give the answer, and testing time we will check the answer given by the system or the answer which is predicted by the system is matching with the answer what we have. If both are same, then I will say that my system is doing well. Otherwise, the my system needs retraining or something has to be done so that the system gives the better result, right? And how this can be done? Sometimes this can be done in batches. So batches is nothing but you can give a small set of input data and then you can give them a full data at the end. So this is how you actually prepare the data. So this is a sample diagram, how we say that the data has multiple dimension. So if I take an image data, the image has height, the image has width, and each image, if I take, it is a color image means we know very well that the color image has RGB. So three channel images, and you have three images means you can see how many samples are available. So this is how unknowingly your data is getting increased, and obviously the solution for that is the tensor, right? So now we know very well you have the data, and what your system has to do, the system has to learn or the system is undergoing a training. What is happening during the training? The system will learn and come to a inference. What do you mean by inference? So here you can see in the first image that you have objects of two classes. The dots are nothing but let's assume that the blue points are supposed to be one particular category and the orange color belongs to another category. So we have two category of objects. So now what happens is you can see that there is a line which is drawn that splits the data. So the first image, it shows that it is the unclassified data. Unclassified data objects are there. And next part, you can see that the area coverage of the orange one holds the orange color data points and the blue coverage has the blue objects. So you can see there is a border which says that beyond this border, the data what we have belongs to different class. How did I draw this line? This is what we call it as the inference or model building. This model building is happening during the training process. So during the training, you draw an inference. That inference says that, so this is a formula and apply the formula, and on that formula I can see if a data is satisfying, if a data is falling into this particular area, it belongs to this particular object category. So that is what we are saying. But one more doubt what we have now is sometimes there is a possibility is that the data points are switched in different place. Even though I said that it is a blue color space, there are some orange points. Even in orange also we have blue points. So what I have to do? So we can go for fine tuning of the parameters. So all those things are there. So there are some general names which are given. We'll see one by one. The first one is the optimization. So what do you mean by optimization is you need to select a best element with respect to one particular criteria based on some iterative steps so that your system is giving the better result and it is behaving effectively. So optimization can be applied to get the best value for a parameter so that you get an effective output. So this is one level of process after you do inherence. We will recollect the process one more time. We have got the data, we are going for model building, and after model building, I'm fine tuning my system by changing values for few parameters. So this optimization is a can be done with multiple algorithms, and in deep learning we have separate area like how we can focus on optimization by selecting the cost function, right? And the next thing, this was the one we were talking about it, that so I have my some data points are falling into different classes. So how do I do it? So here in this diagram, you can see that you have data points of red class, data points of blue class. And you can see that there is a black color line which divides these two classes. And you can see that this is how we got the model inference. Now the problem is, since I could see even after drawing this line, there are some objects which are falling into different opposite classes. So what I'm doing is I'm going for a fine tuning. So when I do this, sometimes what happens is there is a possibility that you can go for a overfitting or underfitting. So we need to see that the system should not fall into that and make sure that you apply enough generalization and regularization methods. So what is the generalization? Generalization is nothing but I cannot decide a ML model by just seeing the sample which I have with me. Because now in this diagram you can see that for this environment I can go for a green color line. But then imagine in a case, a new environment where I'm getting heterogeneous samples. So I need to make sure that when I'm building a model, my model should be very generalized model, right? And then regularization is nothing but I need to prevent the overfitting. We always say this in class also, right? In family also we do this. Sometimes minute things we should not see so that we can escape the macro things, right? So you cannot go in detail for certain things looking for a perfection in a trained data which may affect in the later stage. So the legalization has to be applied properly, right? Yes. So now we have seen this overview. Now we'll go with the deep learning model building. So I told you very clearly, we need to have a clear idea about what is the ANN. So let's start with the fundamental concept of a neural network, which is nothing but ANN. It is artificial neural network. So artificial neural network was designed to mimic the behavior of a human brain, right? So a neural network has interconnected network of artificial neurons. So these neurons are generally called as perceptrons, right? So these neurons are available. Now what are we going to do with the neuron? We are going to connect these neurons and put them into layers. And what is that layer? So we are naming the layers as input layer, hidden layer, and output layer. As I told you that ANN mimics the behavior of a human brain. Now, how actually we do the things? We have some sensors. What are the sensors? We have eye, nose, all these things are the sensors, right? Even ear. And if you look at it very carefully, most of your sensors are located very close to the brain. Am I right? All your sensors are in the face. your eyes are there, your nose is there, your ear is there, right? And you speak something, right? So these most of the sensors are very closely, connected to your brain. And what happens when I see the things? When I see something, I'm feeding that information to my brain, and then brain will be processing it and tells that, okay, this you are at home now, you are at office now, you are seeing a fire, don't touch the fire. Now you're seeing the food, you touch the food. So it is giving some signals to the actuator. Which are all actuator? I'm speaking, my mouth is an actuator, I'm speaking something, I'm walking, so my legs are getting activated, my hands are getting activated, I'm reflecting some emotions, that is again activated. So like how a human has, the same way we have input layer, output layer, and hidden layer is like your brain, right? Which is actually the processing unit of your ANN. So that is what we say. So now the thing is, now everybody will say, right, all of us are having the same brain, but everybody think, thought process is completely different. How it is different? Maybe both the people are born on the same day, right, with the same fate, with the same gender, in the same place, but their thought process is different. Why? What is happening inside the brain? The neurons are connected, and the connections are having some kind of weights. If we see it in a kind of diagrammatic representation, we can see, if this diagram, if you could understand, then it is easy for you to construct a deep learning network, because this is a precise model where you can see that input layer. It starts with the input layer, and you can see in the input layer you have neurons x1, x2 till you have xn, right? All these neurons, we are grouping them and calling them as input layer, and these neurons are input neurons. And what do we have in output? We have the Y layer, Y1, Y2 till we have YL. These are the output neurons, which are, together represents the output layer. And in between, what we have is the hidden layer. What do you see in the hidden layer? When you look at the hidden layer is connected to all the input neurons, and also it is connected to all the output layers, right? And when you see that, the connection is being shown in a line, and that line has some value W. This is what we call it as the weight. So let me take an example. So from Bangalore to Madurai, there may be multiple routes. I can come through train, I can come through bus, I can come through car. So each will have a different time to reach the a place, reach Madurai. So the same thing only here also I can say. So the starting and ending is fine, but I will have different values or different time level. That is what we say the weight, right? So the weight is showing that the connectivity between one neuron to the other neuron. Suppose if the weight is something like, what will be the value for weight? The weight always ranges from 0 to 1. 0 indicates that there is no connection. 1 indicates that it is a high connectivity is between these two neurons, right? Okay, fine. Now, what next? So now what happens is this hidden layer will be getting the inputs from all the input neuron, consolidate that value, and then it takes a decision. How it takes a decision? It transforms the collected value using activation function. Okay, activation function. It transforms the collected input data to the output. Then the output data, again there is a consolidation and a decision is happening, right? So the traditional machine learning, if you take it, what happens is you have an input, you have an output, and what you have between the input and output is handcrafted feature. What do you mean by handcrafted feature? So you know very well the data set will have one table, right? You remember there is the table. The table will be having the values like these are my input and this is the output. This is what you call it as the handcrafted feature. Manually, you have worked on it and then you have labeled the data as cat. But what happens in deep learning is you will give the data as such. Now, the system only will be learning feature by feature, which means that the data will be reduced or the data will be summarized in each and every level. So you can see learned low level feature, learned mid level feature, learned high level feature, finally learned classifier. So the three blocks which we have it in the deep learning, which is actually summarizing in each and every level and coming to a conclusion, right? Okay. So what is the anatomy of a deep neural network compared to your traditional neural network is you also have the layers, but here the thing is layers and weights. Apart from that, the major thing what we have is the loss function and the optimizer. Why do I need this loss function and optimizer is here every level demands the summarization of the data so that I can classify the things effectively, right? So now we'll come back to the previous diagram which we saw. So again you can see the difference between the traditional feed-forward neural network and the convolutional neural network. So if in FNN, if you take that, I cannot give an image. The image will be converted into a structured data or a structured table. The structured table is given to the network, and the network will do the encoding process, do the representation. With that, we do the prediction. But if you take convolutional neural network, which is the deep learning network, which accepts the image and does the convolutional encoder and represent the data, based on that prediction is happening. So you will be telling that, ma'am, there is only one block which is different. What is going to be a big difference with that? So we will deep dive into CNN. I'll take you to CNN. Okay, before that we will see what are the other things we have. So one major area what we have is the CNN in the deep learning. So when I say CNN is there in my deep learning, so what is actually the data processing modules. Again, here also you will be having multiple layers, but the way you extract things from multiple layers are going to be different. Okay, so how it is going to be done? We are going to use some of the techniques which are called as pooling and flattening techniques to summarize the data from one layer to another layer. Okay, so this, as we said, we have the input data and we have the targets. And another thing which we said is the loss function. So what is this loss function? The loss function, what it says is it is actually we need to minimize the error and maximize the output for any type of data. So for that, what we have to do is I need to keep checking my result and improvise my system. So I need to check my output and see whether what output I have got is close to the solution. So which we can call it as these are some of the mean squared error or error computing loss functions, which will help us telling that how far the expected system is away from the actual system. And another thing is the optimizer or optimization technique which has to be used so that we can reach the better results. So there are multiple functions available, like stochastic gradient descent moment, like that. There are variants of algorithms available. You can see the comparison which shows that how I can land up with the best results. So weight updation, when I'm doing the weight updation, I need to see that weight updation, we know it is the learning. So how the learning is happening? So you have given an input, we have taken an output, and we are comparing the input and output using the loss function, and we see that there is a difference in the expected result. Then we will be changing some of the parameters in the system. That is what we call it as the learning. And how do we optimize the weights using the loss function is gives the quality results, right? Now let us pay more attention on the convolutional neural network, because we have understood that this entire deep learning is based on a network called as CNN. And again, there are multiple variations of CNN available, but let us break down the architecture of a basic CNN. So this is a very common diagram which you will find out from internet, but I love this diagram because it conveys what is actually CNN. Let's start from the beginning. You can see that the deep learning always takes input big data as the input. So here you can see the car image is given. And what the system does, you can see that the input is given to the next layer, right? And you can see a part of the image is given to the layer and see the major area of the functionality. You can see the functionality as feature learning and classification. So classification process, we know we have seen artificial neural network where one input layer was there, one hidden layer was there, one output layer is there. But before that, what we have is the feature learning layer. This I have already given here in the first diagram. That is, this is the diagram. See, you directly give the features and do the learning in the traditional ANN or a traditional machine learning network. But in deep learning, what we do level by level, we have to do the feature learning. Am I right? So that feature learning only we are trying to do in the CNN. So here you can see that we are trying to do the layer by layer. We are trying to do the feature learning. How am I doing it? I am repeating a process called as convolution and pooling. So you can see that again convolution and pooling. This process is being repeated to summarize the data. Can you see the size of the box? The box size is getting reduced after each and every layer. So what are we doing is in a traditional ANN or in a traditional machine learning network, we directly give the reduced data. So it is a human who is reducing the data with his intelligence and giving the data for ANN classification. But here, the system with its intelligence will get the actual data and reduce it in each and every layer and give it to the final layer. Now we have got the doubt. So now convolutional neural network is fine. But what is this convolution, ReLU, and pooling? So let's see that. So I thought I will show you some notes so that it really helps you how it is actually done. So I have taken an example here. I hope is my word file is visible, ma'am?
Yes, ma'am, it's visible.
Okay, thank you, ma'am. Okay, so now you can see here that you have this input. So this is our CNN network, how it is going to process. You can see that input and you can see the output. So input, I have given a diagram and you can see some channels, N1, N2, and like that we have channels. And you can see that the first one, what are we doing? Convolutional one, convolution 2, right? In convolution, what are we doing is we are using 5 cross 5 kernel valid padding, which means that I'm trying to read the data in 5 cross 5 matrix and reduce this 24 into 24, next level 24, next level 12 into 12, next level 8 into 8, next level 4 into 4. So what happens from one layer to another layer, the data is getting reduced. How it can be reduced? It cannot be simply reduced. It has to be summarized, which is see, we know very well the concept of reduction is nothing but keep the important ones and then discard the unnecessary things. So the system is going to decide it by summarizing the process. So how is it going to do it? So you can see, assume that this is your data, right? This is my data. So what are we trying to do? So we are going for an image patch multiplied by the kernel. So image patch is the one which I have got the input. I have read the image. And with the image, what are we doing is we are multiplying. This star is nothing but convolutional multiplication. It's not the normal multiplication. It is the convolutional multiplication we do and summarize the data into one value. Can you see 31 is there? So this 31, how did we got? this input, the first matrix, you can see that in the first matrix, 3 cross 3 data is taken, multiplied with kernel, and replaced here. What is the next step I should do? The next step, I should go for the next step. So you can see here that first red color one is the first value. I hope the color is visible. So you can see the red one is taken and filled here. Then it is shifted. It is shifted to the next 3 cross 3 and it is written in this green color. Can you see that? So this is how what we do. We are doing the windowing. So first I am taking, multiplying, summarizing into 1. And I am shifting my window, multiplying, summarizing to the next one. So this way if I try converting, what happens is my 7 cross 7 data will be reduced to 5 cross 5 data. So that is what we are trying to show, right? So here you can see, the entire data is being reduced by this way. So this process is what you call it as the convolutional process. So using the convolution, you could see that the entire image data is being, done this way. And what is the next step? We can see in this diagram what it is given is, you can see one more time, convolution using the ReLU technique. Next is the pooling. So convolution is something like a reducing, and pooling is going to gather everything. So convolution, how it is done, we have seen now, and we are going to see how pooling is also being done. So let's come back to the document. So pooling is nothing but generalizing the features extracted by the convolutional filter. So now a very nice name. It is a convolutional filter. So we know what is a filter, right? Filter keeps what is needed and what does it need. But it cannot be done as such. It is the process of the summarized end result only, right? So now the next step is the pooling thing. So pooling, what are we doing is I have to summarize them. How I can summarize them? I cannot simply do it. There are two type of poolings. We have max pooling and average pooling. So what is this max pooling? So you can see in this diagram, 2 cross 2 pooling is happening. So in 2 cross 2, what are we supposed to do? First, you have a 4 cross 4 matrix. In 4 cross 4 matrix, highlight the 2 cross 2. So in the first highlight, I have 8, 7, 12, and 9. So which is the highest value? 12. So the 12 goes here. The next one, 5, 3, 5, 7. 7 is the highest, so 7 goes here. Then 13, 2, 9, 4, highest is 13 goes here. And here 14, 14 goes here. This is what you call it as the max pooling. Once after you filtered the result, we have taken, the highest value, then it is called max pooling. And what is this average pooling will do? Average pooling will be, we know how to take average, right? The four values are added and then divided by 4. So you can see 8 plus 7 is 15. Then 27 plus 9. And then finally divided by 4, what we got is 12. So like that, the average value. So you can decide that what type of polling are we going to apply, whether we want to go for max polling or average polling. So according to our process, first process convolution is very simple. We should go for convolution multiplication, which is nothing but a windowing technique. The captured image is multiplied with a convolutional matrix and the end results we have received. Like this, when you receive the end result, you need to go for pooling, and pooling you can go for max or average. And then we go for the flattening. Flattening is nothing but the multi-dimensional data is converted into a single strip of data, right? And then we go for building the CNN. So you can see that in the diagram, convolutional layer, pooling layer, then fully connected layer. So we have seen in convolutional layer what actually happening, pooling layer what is happening, and final layer. So the final layer, what actually is happening. Now you can see that one more characteristics of CNN is dropout layer. So what do you mean by dropout layer? So those who have very familiar with ANN, you will be knowing, right? What happens is, now look at, pay an attention here. You are starting with 2 neurons, then with 4 neurons. when these neurons are connected. And in the beginning, I said that the lines are weighted connection. So weighted connections means it's nothing but the connections will have some values. What values? The values can be ranging from 0 to 1. 0 means no connection, 1 means fully connected. So 0 means no connection means do we need the line? We actually don't need the line. If the values are close to 0, then that neurons can be disconnected. So that is what it is shown in the next diagram. So you have the first input neuron, then you have some neurons in the hidden layer. The hidden layer neurons does not have any role to play, which has the very least connection with the input and output layer, which has the values like 0, 0.1, 0.01, like that. So those can be dropped out in the hidden layer. So that is what it is shown without dropout and with dropout. So all these things are final, fine tuning. So we have seen here that you have an input and then the feature learning is happening. The major feature learning is done through the convolutional pooling. Flatten also we have seen, right? Putting the data into a single dimensional values, and then finally we are taking back. Now here what is the thing is, apart from that, we can perform dropout layers to remove the neurons which are not required, and the activation function. So this function we were talking even when we were talking about the ANN. So what does that activation function does is, the activation function will be transforming the data. This is the real intelligence. So I told you, right, there are five people in the same environment, but each of them will take a different decision. Why? Because they have their own intelligence level, right? So the input neuron or the input layer, all the input layer is giving the same data, but output is different. How has it happened is, it is because of the activation function which transform the data. What are the common activation function used in CNN? We call it as ReLU function, softmax function, tanh function, and sigmoidal function. And sigmoidal is very common in ANN. Sigmoidal, tanh, all these functions are very common. Apart from that, the most common functions are the softmax and ReLU function. So what actually it does is, you will be giving the consolidated input value to this function, and this function will be giving you an output. Let me take very simple example. We all know that e power x, right? What is e power x? X is a value given to e power x, then it will give you another output, right? Log of x. So what is log? Log will apply log function. You are giving a value x to the log function, and what you get is a different value. Like log x, like e power x, you have these functions which are called as the activation function, right? So that is how you get the final data, and this final data is flattened, and the traditional neural network operations will be happening. So this is how the convolutional neural network will be working. Now, the thing is, okay, ma'am, we can understand all these things, but when I'm implementing all these things, should I go and work deep level? Not necessary. What we need to know is, we need to know what is inside so that we can customize the things. That is why we are learning. Or you can start from the scratch and do the things also. But nowadays we have lot of frameworks that has the function like a library function. I don't need to construct a CNN. I can simply call CNN and I can give the input. Then I can get the things done. But then everybody can do. Then why do I need to do research? Why am I special? So we can customize the things, or we can do certain work before we give it to CNN, right? So what are the existing deep learning frameworks which we can use? So there are many frameworks which are available, like PyTorch, Torch, Deep Learning, G4J, Keras. Keras is one of the famous framework. Like that, we have different toolkits available. Only thing is, just you need to go install those packages along with your tools and then create them and using it. So I would suggest that you can go with some TensorFlow or else or you can go with Keras and you can choose the Python. Now another doubt will come, ma'am, my system, I don't know whether it will be able to handle this kind of data analytics. So I would say that not necessary. We can go for a web user interface. So web user interface is nothing but you don't need to install that software in your system, but you can use them in the web as you go. Like you have Google Colab, you can go with Google Colab, or you can go with online Jupyter Notebook and use all these things, right? So that way we can actually do it. So as I said, Keras and PyTorch I would be suggesting, and also I thought of yeah, I thought of showing this. 1 minute. So you may be saying that, ma'am, I am a complete new person. I don't know from where to start. Then I would say that always being in a researcher, it is good to first implement what is there available, which is already available. You can try implement and see, and then later on what you can do is you can develop your own model. So I would say that you can just go to this collab or Google Colab. And the best part about Google Colab is it has some kind of resources available. So you can see in the left hand side, data science, machine learning, automation, AI, more resources, featured examples. When you click on this right side, you can see that you have examples like text classification. Like that, you have some examples already. So what you could do is you can just click on them and you could learn about them. So for example, I just want to create a image classifier, right? So you can see build a Keras model on top of a pre-trained image classifier to distinguish flowers. So this is a small project which is already developed. So to learn that, what we can do, step zero, instead of starting with the code, what I can do is I can just click on it and I can learn the model which has been already developed. You will find excellent notes here. You can see the download code is available, and in the code you can see the code how with the comments in the left hand side. You can see here image classification, transfer learning for image classification, object detection, right? So you can see here how to start with the data set. So we told that for the learning the most important thing is the data set. So the data set, what they are doing, they are taking from one zipped folder, flower photos dot tg set. So the data location they are giving it here, and afterwards you can see defining the model. So you how are we defining the model using the Keras? So you can see that how to define the model also they have given, and they have given how many input layers they want. Do they want the dropout? Everything they are mentioning here, and you just need to copy the code and run it here. And you can see that training is happening. So we know very well that ANN is also a supervised model, and deep learning obviously it will be a supervised model. So first step we have to do training. Training is a very simple code. You can see that always in Python they use this fit method for training. So when I'm doing this, right hand side also I can see the comments, and left hand side also I can see the comment. Fit will be helping me to train the data. And you can see that train DS. Train DS is my train data set. If you have any doubt, you can see like they have given data hyphen directory. So directory is given, and then model they are building it here, and then they are compiling it, and then they are training the data using the data set. They are also defining the epo is nothing but how many times I have to run and train. And you can see that for each epo what is the output they have got and what is the accuracy they have got also is mentioned. So the accuracy they say 95, 96, 96, 96. So this is the accuracy, they have got it. And finally, the visualization, right? So the visualization also is shown here. With respect to the training step, what about the loss happen? And with respect to the training step, what is the accuracy? Accuracy, I can see it is flat, right? So means that the accuracy is almost, it is close to 1, which means it is more than 95. So very simple model they have built, and you can see that once after building, they are using it for the classification. So this is the test data they have given, and the output what they have got is the sunflower. So we need to know there is a training phase, there is a testing phase. So when we were training, we used the data set, right? We don't know what is in the data set. When checking this example, you can download the data set and you can see that all the sunflower images are kept in a folder sunflower. Then all the rose images are kept in the folder rose, and it has been given to the system. So the system will know that these flowers, whichever flowers are available in the sunflower. Suppose if I'm seeing a flower which is resemble the sunflower, I need to name it as the sunflower. So that is how it is being done in this example. So this example, maybe you could see that and you can copy the code and you could try with that in the Google Colab or maybe any of the Python directory. So you will able to execute. So this is how it is being done in this example. So like how you do with any other editors. So I'm sorry, yeah. So you can see here you have written like same code only. I mean same category. So you can see here you have written So you can see that first we are loading some packages, then we are splitting the data set, then system is little slow and we are printing the accuracy. So here you can see that accuracy is being something like 63, which means I have to improvise my system, right? So now you may be telling, okay, ma'am, but very examples are very less. So what do I do? So I would also suggest you that you can visit this website called as there may be many websites, but we found it very good. That is Gaggle, and you just give Gaggle and Python, or you can type which application you are interested. For example, crime detection, right? Crime detection and deep learning, right? So I'm just giving this uh, Gaggle crime detection deep learning. Then I'm just going with this. So Gaggle just need a simple sign in. You just need to sign in. Gaggle is a data repository initially, but now it is also a code repository. It has the code also. So it is, yeah, my system is little slow. Just wait for a while. So you could see in the page what is available is, you can see in the left hand side what it has is data set, model, code, discussion. So now when I see that, I can see I will get the data here about the data set, the description. And if you look at very closely, you can see code, bracket 35, which means I have to improvise my system, right? And you can see code bracket 35, which means that 35 people have shared the code for this particular data set. So I'm just clicking on this code data set, right? And you can see that, yeah, it's little slow. So you can see that notebook code. So what you can do is, suppose maybe you're doing it for your students or you're doing for yourself, what you can do, just click on it and then you will get the code, you will get the data, just implement and see. Once after implementation, we can customize this code by changing some of the values, by changing the regularization technique, by changing the optimization techniques, like that. Because as I told you that like this, you can explore the ways how to implement this code. So what you can do is, suppose like this, you can explore the ways how to implement. So you can see people who have shared about crime analysis, all these things. So what you can do is, suppose you are writing a research paper, so it's the best way that you can get the data set, you can see and then change some code here, change the framework here, and the experiment is easy. You get the framework, you get the experiment is easy, you get the result, convert your project into a paper. So this is one of the easiest method. I can share it with you. Since we are closing to the time, I'll just conclude with a few of the applications which are really in demand. So especially if you take deep learning actually works well with the high data. See, at home, when we will cook, if two people, three people, four people, we can manage. Suppose you are having a function where you have 100 people, you will go for a cook, right? Because we cannot manage that time. So 100 people is there, then we can call for a cook. Only one person is there, do we need to call? We will think. Same thing only. The deep learning when we can go is whenever your data size is so high. If your data size is small, it is not advisable to go for a deep learning. You can finish with a normal ANN model. And deep learning is mainly suggested for image and video data. So most prominent applications which are happening around this visual translation, predictive AI, especially audio, video, and image. These areas really demand the deep learning algorithms, right? So with that, some of the projects maybe like I can share it if you really want it, and then going for the learning resources. See, we are computer science teachers are always the learners. We have to learn new things, right? And also we need a recognition for the learning. So recognition in terms of certificates. But most of the certificates are paid course certificates. So some of the courses which I found which are really good, but free courses are available in MathWorks and deeplearning.ai, Coursera, Cognitive Class AI, where you can go enroll for the course and you can get the certificate at free of cost also, and you can add into your resume. That really helps you to learn as well as implement the things, right? So this is how I plan. I think we have 10 more minutes which we can use it for any queries or suggestions. So can I stop here? Any clarifications or doubts? Anywhere should I spend more time? You need explanation? You can tell me. Any questions in chat window?
Ma'am, Haruna, ma'am. Hello, ma'am. Any
Tickets
queries?
maybe.
Any queries from the participant side? Ma'am, Aruna, ma'am.